Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, you know what you're going to do? You're going to find that in physics, there's just a lot of math. That's part of the game. So let's talk about some terms that you've probably heard, particularly maybe in your chemistry class, and they are the issue of measurement or accuracy. Accuracy is how close you are to the actual measurement, because everything has a particular measurement. So let's say that I have a rectangular shaped object, okay? And it has a particular length. So I put a ruler next to it, right, with all its tick marks, and I measure it. And I find out that its measurement is 2.3 meters. But then let's say that I get myself a better measuring device. So similar measuring device, but this one has a lot more tick marks. And I can really get a little bit finer tuned. Maybe even has like these calipers and it can close in on it. And I find that its measurement from the second one, right? This one is 2.3 meters. This one says it's 2.28 meters. You might say, well, those are different numbers. But in reality, they aren't, because they're measuring the same rectangular shaped object. So what does this beg to us? Again, you've learned this in your chemistry classes. This gets to us an issue we call significant figures. You see, they're measuring the exact same object, right? This bar. One's accurate to, we'd say, to 2 significant figures, 2 SF, and this one is accurate to 3 significant figures. And if for some reason I got even a better measuring device, I might find out it's 2.282. You see, I don't really know what that next number is from this device because it's not so hot. This one's better, so I know the third number, or the second place past the decimal. But I don't know what that next number is unless I were to get a more accurate measuring device. And so let's talk about significant figures. I'm sure this is review, but it's not going to hurt us to go over significant figures. And the reason, back up, reasons for significant figures, it tells us how accurate a measurement is. So you don't want to write a big long number with a zillion different things. We want to write a very simple number. So let's talk about how you do sig figs and what the rules are. So it's all about counting. So let's first of all talk about you count sig figures. Okay, there are some rules, all right? Here's rule number 1. Count all non-zero digits. We'll practice in a minute. Trailing zeros count if a decimal. The key on the struggle people always have is, what do you do with the zeros? All right, non-zero digits, they're always significant. Number 3, leading zeros don't count. And captive zeros always count. Let's talk about each of these cases. So if I want to say all non-zero digits count, so this would be number 1 example, 2.32 meters. There are no zeros, they all count. This has 3 significant digits. A trailing zeros, there's actually 2 cases, if you will. A trailing zeros would be something like 200. 200 has no decimal, so this would only count as 1 significant digit. Got it? A little tricky on that. But if I said 200 point, that's 3 significant digits. Or if I said 3.20, there's a decimal, that's also 3 significant digits. All right, number 3, leading zeros, that's where you have like 0.00025. These, by the way, this is a decimal, but that doesn't count because it's part of a 0. It's really 0.0025 right there. And so these are the only significant digits, so that's 2, right? So another one would be 0.0123. That would be 3 digits. This 0 does not count. And then a captive 0 always counts. So if I have 0.0102, now this 0 doesn't count because that's a leading 0, but this 0 does because it's captive, as it's in between the other 2. So counting significant digits, if you understand these 4 rules, you're gold. Now let's talk about how to do calculations with significant figures. And there's really 2 sets of rules. There's add and subtraction, right? What do you do when you add and subtract? Here you keep the lowest place value, write that down. And then if you've got times or divide, multiply, division, then the lowest number of significant figures. The only way to understand this is by doing some examples. So let's say I want to add 2.32 meters. I'm going to add to that 0.205 meters. Now if I were to add this up, now your math teachers all told you to put a 0 right here, but here's the reality is we don't know if that's a 0, do we? Because we don't know what the next, when it's a measurement, we just don't have a good measuring device. But let's just add them up. My calculator, if I were to do this here, I can do this in my head. 5, 2, 5 point, and then 2, 2.525. So is the answer to 2.525? The answer is no, because you see this right here, we need to round to the hundredths place, and so we're going to say 2.53. Now this 5 does round that 2 up. So when you're adding and subtracting, you keep the lowest number of the least accurate place value. Now let me give you one that's going to be like, kind of blow your mind. Well, if I say 300, and I want to add, let's say 18 to it. Now you'd say, Mr. Bergmann, that's 318. And I'd say you're wrong. Because you see, there is no decimal right here. Because since there's no decimal right here, I need to round to the hundreds place. So 318 rounded to the hundreds place is 300. Now you say, that's honestly, this is unrealistic. 300 is a very gross measurement. 18 is more accurate. This is a pretty accurate measuring device to the nearest ones. This is only accurate to the nearest hundreds. This technically is the rule, although very rarely would something like this happen. Now let's do the more common things. What do you do when you multiply and divide? This is where we get kind of all kinds of interesting things. So let's say I want to find the density of an object. So let's say I've got an object that's mass divided by volume. Let's say I've got 2.53 grams, and the volume of the substance was 3.05 centimeters cubed. So I need to now go to my calculator, right, and take 2.53 divided by 3.05. Now the interesting thing is I get this big old number, 0.8295. 0.82950 da 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 da. So do I write the whole number out? Of course not. What I need to do is keep the lowest number of significant figures. In this case, I have 3 sig figs. They're all non-zero digits. This one has a captive 0, but it's in the middle, so they're both 3. So I'm going to round to the third place. So this is 830 grams per centimeters cubed. Now note here, I want to round to the third place. This 9 is rounded by the 5 up, and then I keep the 30. I won't say 0.83, I'll say 0.830 because this 0 counts. It's a trailing 0. And so you round to the appropriate level. Don't just write out the big long number. So when you're multiplying and dividing, what you do is the lowest number of significant digits. And by the way, when in doubt in this class, don't write 10 significant digits. We have no measuring devices that are that good. Probably 3 is a pretty good rule of thumb. That's why I chose 3, by the way. So significant figures, not so difficult. It's all about following the rules, knowing the rules. Houston, this is not a problem. See you in class.